So friends, continuing from the last lecture, I was at this divisibility rule of 16. So I was trying to connect the divisibility rule of 16, 32, 64, 128, 256 with divisibility rule of 2, 4 and 8. So what does the divisibility rule of 16 says that for divisibility rule of 2, last one digit, for divisibility rule of 4, last two digits, for divisibility rule of 8, last 3 digits, for divisibility rule of 16, last 4, for 32, last 5, for 64, last 6, for 128, last 7. Why? Because it depends upon the respective powers of these numbers in the terms of 2. The point is that if a number has to be divisible by 2, you need to understand this thing, that if a number is divisible by 2, then obviously that if a number is divisible by suppose 2 to the power 9. So what is 2 to the power 9? 2 to the power 9 is 2 into 2 into 2 into 2 into 2, 9 times. So the point is, if there are 9 2's in a number, and if you are dividing a particular number by 2 to the power 9, then obviously that original number should also have 2 to the power 9 in it, in order to get exactly divisible by 2 to the power 9. Suppose this is number n. I divide this number n by 2 to the power 9. Now, if this number n has to be divisible by 2 to the power 9, there should be at least 9 2's in this number. Then only this number n will be divisible by 2 to the power 9. That is, what is this? 2 into 2 into 2 into 2, 9 times. And in order to get this number n divisible by 2 to the power 9, there should be at least 9 times 2 in this number n. 9 times 2, that is 2 into 2 into 2 into 2 into 2, 9 times. Then only this number n will be divisible by 2 to the power 9. The same logic applies here. In order to get a number divisible by 16, what is 16? 2 to the power 4. So, if a number has to be divided by 2 to the power 4, then there should be at least 4 2's in the original number. What number I have taken here? A, B, C, D, E, F. If I write A, B, C, D, E, F as AB into 10 to the power 4. Now, there is a logic behind writing this number as AB into 10 to the power 4. Why I have taken 10 4's here? Sorry, why I have taken 4 10's here? The point is, in a 10, there is a 5 and a 2. So obviously, if a 10 is there, a 5 and a 2 is there. So obviously, that much amount of 10's are there, the number will be divisible by that much amounts of 5 and that much amounts of 2. That is 10 to the power 4 is there in this number AB into 10 to the power 4. Then this number AB into 10 to the power 4 will be divisible by 2 to the power 4 and will also be divisible by 5 to the power 4. Because 2 to the power 4 and 5 to the power 4 are factors of this number, AB into 10 to the power 4. This is what I am trying to explain to you. AB into 10 to the power 4 is, you can also write it as AB, can also write it as AB 2 to the power 4, 5 to the power 4. So obviously, this number AB into 10 to the power 4 will be divided by 2 to the power 4 also, 5 to the power 4 also. So that is why I took these 4 zeros. That means this number will automatically give a remainder of 0 by 16, and then what will be the remainder will be dependent upon? It will be dependent upon this remaining 48 number, that is C, D, E, F. This is the whole point of solving this question. How much dependent? Dependent on these 4 numbers, C, D, E, F. That is, if these 4 numbers are divisible by 16, the whole number will be divisible by 16. I hope you are getting my point. So, what I am going to do this for this 32? For this 32, I will take 5 zeros, and we know that 5 zeros will be different, and that expression will become divisible by 32, and what will be left? The last 5 digits. So, for 64, last 6 digits, for 128, last 7 digits, for 256, last 8 digits. You can also learn it. Divisibility rule by 2, last 1 digit. Check the divisibility of 2 by last 1 digit. Divisibility rule of 4, last 2 digits. Check the divisibility rule of last 2 digits by 4. Divisibility rule of 8, check the divisibility of last 3 numbers by 8. Divisibility rule of 16, check the divisibility of last 4 numbers by 16. Divisibility rule of 32, check the divisibility of last 5 numbers by 32. Divisibility rule of 64, check the divisibility of last 6 numbers by 64. Divisibility rule of 128, check the divisibility of last 7 numbers by 128. Divisibility rule of 256, check the divisibility of last 8 number by 256. These whole things are related. That means that the divisibility rule of the powers of 2 goes in a particular fashion. That is 2 to the power 1, 2 square, 2 cube, 2 to the power 4, 2 to the power 5. This is going on in a particular fashion. But at this point of time, I would like to tell you one thing, that please don't relate this thing with the divisibility rule of 3. That is, I told you in the divisibility rule of 3, I told you that if I'm going to add all the numbers and divide by 3, and if the number which has came is divisible by 3, then original number will also be divisible by 3. In the divisibility rule of 9, I told you that add all the numbers, and if the resulting number is divisible by 9, then the original number is also divisible by 9. But if there is another number, so that is, what is 3? 3 to the power 1. What is 3 square? 9. What is 3 cube? 27. But in the case of divisibility of 27, I cannot say that if I have to check the divisibility of a particular number by 27, then I am going to add all the digits of that number and divide by 27. And if the sum of all the numbers is divisible by 27, I will say that it is also divisible by 27. No, this is not the logic. This pattern is same for the powers of 2. But the pattern that I have followed for the divisibility rule of 3 and for the divisibility rule of 9 in the coming lecture, that will not necessarily apply for the divisibility rule of 27, for the divisibility rule of 87, for the divisibility rule of 243, for the divisibility rule of 729. That is the higher powers of 3. That I will explain in my subsequent lectures. I hope this much more is clear to you. So, divisibility rule of all the powers of 2 are clear to you now. This one is an easy one. This is a number A, B, C, D. Again, I am taking a 4-digit number. The point is, I am taking 4-digit number as a reference number. The divisibility rule, the logics that I am telling you, they are applicable in numbers of any quantity. 4-digit number, 28-digit number, 39-digit number, 3956-digit number. It doesn't matter. So, this is a number A, B, C, D, 4-digit number. I have to check the divisibility rule of A, B, C, D. Divisibility of A, B, C, D by 5. So, the point is, in this case, I can write it as something like this. 8 to 10 cube, you should now be very much accustomed to it. I have used this thing a lot of times, into 10 to the power 0, 10 to the power 1, divisibility by 5. I have to check the divisibility of A, B, C, D by 5, so I have to check the divisibility of these individual terms by 5. So checking the divisibility of A to 10 cube by 5. What is the divisibility of 10 cube by 5? Divisibility is 0. That is, 10 cube is 1000. 1000 is always divisible by 5. So it doesn't matter what is the divisibility of A with 5, because if this 10 cube is divisible by 5, then this whole number will become divisible by 5. Coming to B into 10 square. Divisibility of B with 5 doesn't matter, because I have seen that this 10 square, that is this 100, is divisible by 5. So if this 10 square 100 is divisible by 5, then obviously the remainder is 0 here. So the remainder of B by 5 doesn't matter, because the overall remainder of this whole term by 5 will come out as 0. So this also 0, this also 0. This number, C to 10 to the power 1. 10 to the power 1, that is 10 divisible by 5. So 10 to the power 1 will leave a remainder of 0 when divided by 5. So whatever the remainder C will leave with 5 doesn't matter. So the whole remainder will become as 0. Now what is remaining? Sorry, this is something plus. Now it is remaining D into 10 to the power 0, that is D into 1. So what is this? This is the D. So this is 0 plus 0 plus 0 plus D. This is 0, this is 0, this is 0, what is D? So automatically the remainder of this A, B, C, D is dependent upon this last number, D. That is, if D is divisible by 5, then this whole number is divisible by 5. So, in case of divisibility rule of 5, this D can assume two values, 0 and 5. This is simple. That in order to a number to be divisible by 5, its unit digit should be either 0 or 5. The divisibility rule of 5 is simple, and I know that 99% of you guys will be knowing this thing, that in order to find out the divisibility rule of 5, what we have to deal with? We have to deal with that we have to see that whether the unit digit of the given number is either 0 or 5. If it is either 0, then also divisible by 5. It is either 5, then also divisible by 5. What's the reason for that? I told you. The reason of divisibility rule of 2, the reason of divisibility rule of 3, the reason of divisibility rule of 4, the reason of divisibility rule of 5, the reason of divisibility rule of 8. 16, 32, 64, 128, 256, 512, 1024, 2048, 3000, what will be the next one? Into 2, sorry, 4096, and so on. So, whatever divisibility rules that I have told you till now, my perspective of telling you the divisibility rules is that you should not learn the way these divisibility rules are given in the books. You have to understand these divisibility rules from the very base from which they are made. And after knowing them from the very base, you will be able to interrelate these divisibility rules with the concepts and with the questions that you are going to face in your examinations. Whether those questions are of subjective nature or whether those questions are of objective nature. It doesn't matter of which nature they are. It simply matters how you are going to deal these things. And how you are going to understand the concepts, analyze the concepts. So, moving forward. This duster is going way by. Now we are going to see the divisibility rule by 6. If you have to check the number of divisibility of number by 6, we have to check the number of divisibility of the number by 2 and by 3. That is, if a number is divisible by 6, then it must also be divisible by 2 and divisible by 3. Obviously, if a number is divisible by 6, it will be divisible by 3 also, it will be divisible by 2 also. Because these 2 and 3 are factors of 6. That is, if any number n is divisible by k, so if a number n is divisible by k, then the number n will also be divisible by the factors of k, each and every factor of k. This I have told you while taking up the concept of prime factorization. So, divisibility rule of 6 is equals to divisibility rule of 2 but divisibility rule of 3. This is dr represents divisibility rule. Divisibility rule of 6 equals to divisibility rule of 2 plus divisibility rule of 3. Suppose a number 8, 9, 1, 6. This is a number. I have to check the divisibility rule of this by 6. So what does the divisibility rule of 6 says? That divisibility rule of 6 is the summation of divisibility rule of 2 and divisibility rule of 3. We know the divisibility rule of 2. The divisibility rule of 2 simply says that the last number should be divisible by 2. That the last number should be divisible by 2. That means the last number should be even. What is the last number of this number 8, 9, 1, 6? 6. So this number 6 is divisible by 2. So this number 8, 9, 1, 6 is also divisible by 2. So as far as the divisibility of this 8916 by 2 is concerned, 8916 is divisible by 2. We knew that this 8916 is an even number, is divisible by 2. Coming to divisibility rule by 3. If I have to check that whether this number 8916 is divisible by 3, what I am going to do? I am simply going to add all the digits of this number 8916. So what I will get? 8 plus 9 plus 1 plus 6. So what is this? 8, 9, 17, 18, 16, 6, 24. So I got 24. Is this number 24 divided by 3? If I divide 24 by 3, I will get it as 8. That means this number 24 is divided by 3, divisible by 3. So I can say that this number 8916 is also divisible by 3. I use a simple method for the divisibility rule of 6. I applied in conjugation the divisibility rules of 2 and divisibility rules of 3. By applying the divisibility rule of 2, I saw that this 8916 is an even number and is divisible by 2. While applying the divisibility rule of 3, I found that this 8916 is also divisible by 3 because the sum of the individual digits of 8960 came out as 24 and this 24 is divisible by 3. So I can say that this whole number 8916 is also divisible by 3. I hope you are getting this point. So 8916 also divisible by 2 and by 3, 2 and 3. So also divisible by 6. This 6 is 2 and 3. So divisibility by 6 is proved in front of you. I hope this thing is making sense to you. Let us take one more example. 8, 5, 8, 6, 9, 7, 8, 3. This is a number. Suppose I add 4 through this. Now this number 858, if we calculate the exact quantity of this thing in Indian counting system, how much will it come out as? 85 crore 86 lakh 97,834. 85 crores 86 lakhs 97,834. Now if I have to check the divisibility of this number, this 9-digit number, by 6, automatically I have to check the divisibility rule by 2 and 3. Is this number divisible by 2? Yes, because the unit digit is 4, and unit digit is 4. This 4 is divisible by 2. This 4 is even, so this whole number is also divisible by 2. So it is divisible by 2. Coming to 3, is this number divisible by 3? Let us check out. I have to add these numbers. So adding 8 plus 5 plus 8 plus 6 plus 9 plus 7 plus 8 plus 3 plus 4. Let us see what I got here. 6, 9, 7, 8, 3, 4. So this is 21 and 15, 36 and 15, 51 and 7, 58. So I got the sum of these digits as 58. 3 plus 4, 7, 7, 8, 15, 57, 22, 22, 9, 31, 31, 6, 37, 37, 8, 45, 45, 5, 50, 50, and 58. So is this number 58 divisible by 3? This number 58 is not divisible by 3. So, not divisible by 3. So this number 858697834 is not divisible by 6, because it came out as divisible by 2, but it didn't came out as divisible by 3. So this is the whole logic. Now, if I am going to add one more number to this 2, that is, now this number becomes something like this: 8, 5, 8, 6, 9, 7, 8, 3, 4. Now, and 2 more. This is a different number, this is a different number. Mark it as 1, mark it as 2. Now is this number divisible by 6? This is divisible by 2, because the even digit is 2 only. So, this number is divisible by 2. But whether this number is divisible by 3, add all those numbers. If you are going to add them, you are going to get 60. This 60 is divisible by 3. So if this 60 is divisible by 3, this number is also divisible by 3. So divisible by both 2 and 3. So this number is divisible by 6. So this is divisibility of 6. So friends, thank you for watching my lecture. In my next lectures, I will tell you about more divisibility rules, some more divisibility rules. Thank you for listening.